For my third example here, we're going to look at a slightly different form of your basic exponential function. Remember, our basic exponential form is y equals a times b to the x. Okay. Now this is what we have seen so far. A lot of times though, when we are dealing with real life applications of things that can be modeled by exponential functions, which is a lot, by the way, a lot of different situations. A lot of times when we are modeling, we use a slight variation where we have y equals a times 1 plus r to the t power. Okay, so very similar still. Very similar because a still tells us the y-intercept, or the original or starting amount. This 1 plus r altogether still tells us what b is, what our growth rate, or what our rate of change is. But if we look at the r specifically, r tells us the percent of growth or decay. Written as a decimal. And then x, or t, will refer to time. Okay, so again, a very similar equation, just slight variation on it, but that might make some of these applications a little easier to work with. So speaking of applications, let's do one. Example 3a here. Suppose you invest $500 in a savings account. That pays 3.5% annual interest. How much will be in the account after 5 years? So this is also assuming that we're not adding any extra money into this bank account along the way, or we're not taking anything out. But all of these different types of accounts that you guys have or will have in your future deal with exponential growth. All of this percent interest, credit cards, mortgage, student loans, all this stuff, all deals with exponential growth. So again, very applicable in your lives. Here's our situation. Since we're modeling, let's try to work with this equation. Y equals a times 1 plus r to the t power. Okay, let's try to come up with our equation. $500 is what we invested. That's our starting amount. It's our a value in this case. So we have y equals 500 times 1 plus r is our percent written as a decimal, our percent growth or decay. Since our account is giving us 3.5% annual interest, that r value is going to be positive because our balance is going to be increasing. 3.5% written as a decimal would be 0.035 to the t power. And then to figure out how much is going to be in the account after 5 years, we'll just take 5 and replace t. 500 times 1 plus 0.035 to the 5th power. Calculator here. Is $5,993.84. Okay, since we're talking about money, we'll look at the nearest hundredth, um, and it was a 3 after the decimal point. Okay. It's $593.84. There is an example 3B that's still dealing with applications. It looks pretty different from this though, where it's matching different situations with equations. So even if you think you got this one, it might not hurt to look at the B example quick just to try some matching on your own.